I hope you guys just did well on your quadratic formula quiz. And today and tomorrow the focus is real world. So today we're going to do some notes together. Tomorrow will be a practice type 3 that is going to get graded. So make sure you guys do put your best effort into that. You are going to get 2 type 3s really close in a row, and I know you guys are going to complain about it. One is centered on real world, and one is just centered on a focus on all the factoring we've been doing throughout this section. So one's a real world, one's just skill-based solving. The type 3, even though we're doing it in class tomorrow, if you want to get a head start on it today, if copies are made, then you could get a head start on it tonight on top of the additional homework that you have. You will have a few nights to do it. So the type 3, you'll have be able to work on it on tomorrow and the next day. But keep in mind you're getting another type 3 that you'll also have 2 nights to do that. So they overlap by 1 night. I don't know if that makes any sense. So it's like 3 nights of homework of type 3s, but they share one overlapping day. So you'll have 1 night where you have both type 3 assignments that you can work on. So 2 nights for the real world, and you'll get 2 nights on the skill-based, but they overlap by a night. So let's go ahead and get started with the real world. We previously did real world examples with a main focus on vertex. Vertex will still pop in today and tomorrow, but the main goal is to solve for x. Anytime you're given a real world scenario, you really have to ask yourself, what is this problem trying to get me to find? So for example, if I just draw a sketch of something, okay, like an object that goes up and comes back down. Got to make sure you read the question. So I might be asked, find the maximum height, or find the time it takes to reach the maximum height. If you see those words, that means it's talking about the vertex. In this case, it's a max, but if the parabola was flipped, it could be a minimum, like find the minimum. And then other synonyms that mean that, like the highest, the lowest, the least, the greatest, the most, the highest, those sort of vocabulary terms are referring to the vertex. Or you just try to visualize the problem, and even if it doesn't use those words, if you think back to that clown example we did way back in the first section, we wanted to know if we hit the ceiling. It didn't use those words, but if I want to know if I'm going to hit the ceiling, that's a vertex question. I need to figure out how high it goes, the highest it goes, the maximum it goes. So those are what we did prior. Most of the ones that we're going to focus on the next 2 days are going to look for other parts of the quadratic. So maybe the question will say, when will it hit the ground? If it's asking when it'll hit the ground, that's referring to an x-intercept. Well, we know how to solve now. We find x-intercepts either using the square root method, factoring, or the quadratic formula. That's how we find x-intercepts. Or the question might ask how many seconds until it is, say, at a height of 25, which will happen on the way up and on the way down. It's still asking for those x values. So even though they're not x-intercepts, you would still find these x values using the square root method or factoring or the quadratic formula. You're just at a different height. So this problem was at a height of 25 versus being on the ground when you're at a height of 0. But solving for those x values is still the same strategy, the 3 methods that we've been practicing the last 10 days. So read the question, make sure you know what it's really asking about, and then if it's a vertex question, you got to use those old skills like negative b over 2a or h and k or averaging the x-intercepts. But if it's a new type question where I'm trying to find either a random x value on the parabola or where it hits the ground, then you have to apply our new solving strategies of the formula, factoring, or square roots. So if I just pull up the handout that you guys are going to be getting today, and we're taking our notes in here, at the very end is the homework. There's not too many on the homework assignment, which is why if you want to get a start on the type 3, I think it would be a good idea to get a head start on it tonight and be motivated. Please and thank you. So there's two formulas. We have a falling object formula and an object that has been thrown, that has some force behind it. In both of these formulas, they have overlapping variables. So in the formulas, h of t, okay, apparently, I'm going to hit pause on the video real quick because when my computer does that, that means I need to close my documents and reopen them because they've been open for too long. So I apologize. Hit pause. I'm going to fix this and come right back. It's still not letting me open this up. Don't know why. All this stuff is open. Apparently I can't hit pause, guys. There we go. Technical difficulties. Hopefully you guys aren't just listening to nothing. All right, let's try this again. So in both of these formulas, they have some common variables that represent the same thing. In both equations, h of t is representing the height of the object, either as it's falling or as it's being thrown. So that height can change over time, which is what the t variable is. It's going to be the time in seconds. Also, the height for these examples will be in feet. You'll see later tomorrow on some of the worksheets that when it's not feet, you won't see a negative 16 there. It'll be a different variable. A different variable is used for meters because the unit's different. The h sub 0, which is pronounced h naught, like if you get a knot in your hair, is standing for the initial height. So the height at which the object is being dropped from or thrown from. And the v naught, which is only in the second one, is standing for the initial velocity, which is like the speed behind the object, because it has a little bit of oomph behind it, because it's being thrown or it could be kicked, etc. So that's what those variables stand for. When we do these real-world scenarios, you're either going to have to write your own equation using those formulas, or if a formula is already given to you, you don't have to try to write your own. You're going to use the one they gave you. So you only use these formulas if you don't have a function, and it's a falling object or an object that's being thrown. But if one's already there, don't try to reinvent the wheel and write another one. Use the one that you were given and analyze the information to figure out how to solve it. So for number 1, it says a stuntman is working on the set of a movie and is going to fall out of a 100-foot window above the ground onto a safety cushion that is 26 feet wide by 30 feet long by 9 feet high. I'm going to come up with our model first. So when you're writing the model for the function, the only thing you're going to sub in is the h naught and the v naught, depending on what type of problem it is. This man is falling out of the window, so we're going to be using our falling object formula. So nothing is going to get subbed in for h of t, because his height is changing as he falls. Negative 16 t squared, time is changing as he falls, plus then we sub in our initial height of the man, which is 100 feet. That is our model that can be used to predict the man's height as he falls or the time as he falls. So for part B, it says how many seconds will pass until he reaches the cushion. So I don't know the seconds. We don't know t. So therefore, we have to sub in something for h of t, which is his height. When he reaches the cushion, we have to know his height. So let's look back to the paragraph for that information. His height when he reaches the cushion is 9 feet high. So 9 is going to go in for h of t. Any falling object problem can be solved using square roots because the following object formula does not have a middle b term. So we can solve it by square roots, and decimals are always okay. So we're going to subtract over the 100. We get negative 91 equals negative 16t squared. Don't be too quick to square root. We're going to first divide by negative 16, and we're going to get a decimal. That's okay. Don't round till the end, though. Negative 91 divided by negative 16 is going to be 5.6875. I wrote the whole thing. Sooner you round, the less accurate your final answer will be. And then to get rid of the square, we square root both sides. Normally, we put a plus or minus sign when solving by square roots, but in the real world, most of the time, the negative answer won't make sense. T is talking about time. I don't want a negative time, so I'm only going to want the positive version of this radical. So when I square root 5.6875, I'm going to get 2.385. And I'm rounding to the thousands place because that's what our department is encouraging us to do to prep you guys for the SATs, because you'll have to round to the thousands place on the SATs. Always label. Not only am I going to label the number, but notice I labeled the variable. I want to know what variable you're finding and what that variable represents. So we're finding t, and t represents 2.385 seconds until he reaches that cushion. We're going to repeat this problem again, but we're going to be a little cruel. Instead of hitting the cushion, when he fell, he missed the cushion. They didn't put it exactly where it needed to go, and he's going to hit the ground instead. I'm going to erase this so I can scroll down. Any question that says hits the ground means the height is at 0. Ending height is at 0 on the ground. Our original model does not change, so the initial height is still 100, but this time we're subbing in 0 for h of t instead of the height of the cushion. So this all stays the same. The negative 16t squared plus the initial height of 100. Still solving by square roots, because it's still a falling object problem. Subtract over the 100. Divide by negative 16. Negative 100 divided by 16 is going to be 6.25. And we're going to go ahead and square root both sides. Still don't want the negative answer because that won't make sense. And we're going to get 2.5 seconds. Again, label it and tell me what variable you were finding. Two things that are important that I would look for. What variable are you finding and what does it mean? So it only takes a little bit longer to hit the ground versus the cushion. That's an example of the falling object. You'll see in the homework part of this packet that a lot of those homework questions are falling object examples. So if I said I was falling out of a 13,000-foot plane, what would you sub in for h sub 0, h naught? Yep, it would be 13,000. If I fell off my deck in my backyard and my deck was 20 feet high, what would be the h sub 0? The 20 feet. The h of t depends on what the question asks. So if the question was, when will I hit the ground, which is what most questions will ask for, h of t is 0. The trickiest falling objects ones would be, when are you halfway to the ground? So for like the skydiving one, if I was falling out of a 13,000-foot plane and I wanted to know how long until I'm halfway to the ground, and of course there are other things that would come into play that would turn this not into a parabolic example, but I'm just throwing this out there. The h naught would still be 13,000, that's the h sub 0, but h of t, if we're halfway down, would be 6,500. So halfway, you're just essentially taking half of that. And that's what you would sub in for h of t and solve by square roots. Let's talk about number 2, which is a little different. So you have a powerful crossbow. I don't even know what that is. I'm sure it's something that you'd see like in the Hunger Games. And it's going to fire a bolt. I'm guessing that's what they call the arrows that they shoot. Upward from a deck of the deck that's 10 feet off the ground with an initial velocity of 320 feet per second. One thing to note about the initial velocity, if you're shooting in an upward direction, velocity is positive. If you're shooting in a downward direction, then the velocity is going to be negative. So here, this has force behind it. It has speed when you shoot this bolt. Therefore, it's not a falling object. This is going to fall into the throwing formula. Even though we're not throwing it, it would still be the same exact formula. So we're going to write our function that can be used to answer all follow-up questions. It's going to be h of t equals negative 16t squared plus our velocity, which is 320 times t. Don't forget that t in the middle because you need that b term. That's what makes this different than a falling object. And then plus the initial height, where it was being shot from, which was the deck 10 feet up. There's our model. Trinomial, standard form, 3 terms, can't use the square root method to solve. So how many seconds will pass until the bolt hits the ground? Hitting the ground again means we have to go ahead and sub in 0 for h of t. I'm just going to scroll up a little bit and rewrite the model so that way I have enough room to do out the problem. Sorry about that. I'm just going to rewrite it. So I'm subbing in 0 for h of t, and I want to see that. Don't skip that step. Don't go right to the solving method. Show me subbing in 0 that you realize that the ground is a height of 0. That's important. I normally take off points if I don't see that step. Okay, so I just rewrote it, subbing in 0 for h of t. As I was saying, there's a b term here, so I can't use square roots. I am not going to attempt to factor that. Most likely, if it's a real-world situation, the answers are going to be all these messy decimals, so it's probably not going to be factorable. Chances that it's factorable is slim. You could try, but it won't work. So let's go ahead and apply the quadratic formula. That's our third way of solving when there's a b term present, and it's already set equal to 0. Instead of x equals, it's going to be t equals, so identify the variable we're finding. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, and I'm using this strategy of solving because nowhere did it say find the maximum height of the bolt when it was shot. So this is not a vertex question. Did not indicate I need to find the highest that it goes. So it's asking hitting the ground, which is an x-intercept, so I have to use one of my solving strategies. I'm going to keep working through this. Chances are you're going to have to always write small when you're doing these real world because the numbers are going to be pretty long and messy. I'm going to square the 320 to get 102,400. I have 2 negatives with the 4ac, so it's going to become a plus. And 4 times 16 times 10 is going to be 640. And the denominator is negative 32. Keep working under the radical, add those numbers together. And I get negative 320 plus the square root of 103,040 over negative 32. If this was not a real world problem, I would say, see if the number comes out of the radical, stays in, or you break it apart. But for real world, we are always going to take it out, regardless of whether it's a perfect square or not. So I will square root that number. Not going to be a whole number most of the time. In this case, it's 320 all around to the thousandth place, 0.998. Again, the sooner you round, the less accurate your answer is, so you don't want to round too soon. And it's still over negative 32. Because there is no longer a radical once you square root, we have to now split this apart and add and subtract and divide to get 2 exact answers. So we're going to do negative 320 plus 320.998 over negative 32 and see what that equals. And negative 320 minus 320.998 divided by negative 32. Because if there's no radicals or imaginaries, you can combine your numbers together. This is where a lot of students get stuck. So if I do the first one, negative 320 plus 320 is going to be 0.998 over negative 32, which is going to be negative 0.03. And remember, we're solving for t that we identified earlier. So that's a second. Label that answer. Even if it doesn't make sense, still label it. And the other one, we're going to get negative 640.998 over negative 32. I'm doing that on my calculator right now. And that's going to give me positive 20.03 seconds. So one's negative, one's positive. The negative answer is not going to make sense hitting the ground. So the positive answer is the one that we're going to use. It'll take 20.03 seconds to hit the ground. I prefer a sentence over just a label to make sure you're actually addressing what the question was asking. Okay? So that's how you do part B, solving, hitting the ground. If we go to the next page, this is going to clear out now. There's still 2 more questions. I want to know this time how many seconds until that bolt would hit a height of 30 feet. The model is no different. It's still h of t, actually I'll write up here, equals negative 16t squared plus 320t plus 10. That hasn't changed. What's changed is the height of the bolt. Instead of hitting the ground, I want to know when it's at a height of 30. So you will not sub in 0 for h of t. We're going to sub in 30 for h of t. It's a height, not a time. So you do not sub it in for t. This is still not referencing the maximum. It doesn't say find the highest point. So it's not a vertex question. So I have to solve that. To solve it, you got to set it equal to 0. So we're going to subtract the 30 over. You're going to have to write small for this one. And once it's equal to 0, you're going to repeat doing the quadratic formula again. The only thing that's going to change is your c value. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. I know it's repetitive, but the more you practice it, the better you're going to get at it. This will become negative 320 plus or minus the square root. I squared 320 earlier. I'm not 100% sure I remember. I think it's 102,400. Yep, 102,400. Then I have negative 4 times negative 16 times negative 20. That's 3 negatives. An odd amount of negatives stays negative. And if I multiply those, ignoring the signs, I'm going to get 1280. So I've already predetermined my sign. Over negative 16. Not negative 16, sorry, over negative 32. If you want to leave behind the negative 32 and bring it back at the end, you can save some space, but I'd be afraid of you guys forgetting about it altogether. If I combine under the radical, okay, 102,400 minus 1280 is 101,120. I'm going to come up here. Because it's a real world problem, you square root that no matter what, even though it's a decimal. You take that square root. Negative 320 plus or minus. When I square root 101,120, I'm going to get 317.994 over negative 32. And now that there's no radical, we can again break the plus and minus apart. So I'll have negative 320 plus 317.994 over negative 32. And negative 320 minus 317.994 over negative 32. First one, negative 320 plus 317.994. It's going to give me negative 2.006 divided by negative 32. And if I divide that, I'm going to get 0.063 seconds. And then the bottom one, negative 320 minus 317.994 is negative 637.994 over negative 32, which will give me 19.937 seconds. Both of these answers are positive, so both of these answers should make sense because it's going to hit a height of 30 feet on the way up and on the way down, whereas hitting the ground, it only does that once. So I'm going to go write a sentence. So it will reach a height of 30 feet at 0.063 seconds and 19.937 seconds. So key things here, always label what you're finding. I'm finding T, and label your answers with their unit. Those are seconds. And then write a sentence. We're almost done. We have one more follow-up question, and the remaining time you guys can start your homework in class. So this last part is wanting the maximum height. This is a completely different point altogether than everything we've done so far. Maximum height, that word maximum, means this is a vertex question. Nothing to do with the quadratic formula. So we're going to still use our model. That hasn't changed. And find the vertex of this model. When you find the vertex, you always find the x value first, and t is in the x location. So when we find the vertex, we're finding time first, not height. So even though I want height, I can't get the height until I get the time. So I'm going to do negative b over 2a because this is in standard form. Okay, that's going to give me negative 320 over negative 32. And if you go ahead and divide that, you are going to get 10. Just to reiterate the work I just showed, I labeled this as T to help me remember that this number is talking about seconds. So it takes 10 seconds to reach the maximum height, but that's not what the maximum height is. To find it, we're going to go ahead and sub that in. That's kind of a little unrealistic number, 10 seconds to reach that max height, just because that's a long period of time for the arrow to be in the air. But we're going to go with it anyway. We're going to sub in 10 to find the height of our vertex. So negative 16 times 10 squared plus 320 times 10 plus 10, because the C value was already 10. And work through this. Square the 10 to get 100. And get negative 16 times 100. Plus in the center here, we're going to get 3,200 plus 10. Keep going. Negative 1,600 plus 3,200 plus 10. And if I combine from left to right, I'm going to get 1,610. Label that. That's our height that we just found in feet. That is our max height. And that's pretty much a summary of these real-world scenarios. Read it, think about what it's asking for, and how you find it. So we have two formulas that you guys are going to have to memorize. I'm going to clear this out so I can reference those again. There's the falling, there's the throwing, and then there's technically a third one that's not here, and that would be the equations given to you. So if I gave you an equation, you use the one that's given and figure out what you have to sub in and how you solve. If it's asking for the highest, the most, the maximum, it's a vertex. That's completely unrelated to trying to find questions like in part B and C, where find it till it reaches a height of 30, or when will it hit the ground. That's solving for not the vertex, but other points, and we find those other points either using the square root method, factoring, or quadratic formula. If it's throwing, you're going to do quadratic formula. If it's falling, you're going to do square roots. And if for some reason I give you an equation that's factorable, then you could try that method as well. So your homework, you have some problems here. You're going to read through those and try those tonight for homework. And if you wanted to get a head start on the type 3 that you'll get tomorrow, you can ask for that, because tomorrow will be the only day that you get in class to work on the type 3. And that is it.